Hello, and welcome to 5-Minute Math. Today we are looking at the 5th grade concept of classifying 2D shapes. This is 5.5a Readiness Practice, the advanced version. If you are interested in exploring the 5.5a Readiness Practice for the intermediate or proficient versions, or the Readiness Practice resource along with any other standard, you can find those by using the link in the video description. So we are creating a Venn diagram here to show the relationship between rhombuses and rectangles. Now, what do we know about a rectangle? So a rectangle here is a quadrilateral. Specifically, it's a parallelogram that has 4 right angles. So that's what makes a rectangle a rectangle. Parallelogram, 4 right angles, or we can think of them as 4 square corners. Now, what is a rhombus? A rhombus is when a lot of times we kind of think of it like a diamond. So I'm going to try to draw one for you here. If we're thinking of the pattern blocks, we actually have 2 rhombuses. It's the blue one and then the beige one. Those are both rhombuses. It is a parallelogram that has 4 equal sides. So that's what makes a rhombus a rhombus is it has 4 equal sides. So let me label these for you here. So I've got my rectangle and then my rhombus. Now, here's the question. Are they completely separate? If they are completely separate, then we'll have to land with Jeremiah, and you can't have a rectangle be a rhombus. If they have a little bit of overlap, right, then that's going to be Eloise, and if one lives inside the other, then that's going to be DJ. So that's what these represent. Now, here's the question. Can I have a shape that has 4 right angles and 4 equal sides? We know that they're not going to be the exact same. Every rectangle is not a rhombus because I just drew a rectangle right here. That is not a rhombus. It does not have 4 equal sides, so that's not going to work because when the rectangle circle is inside the rhombus, that means every rectangle has to be a rhombus. And I can draw a parallelogram with 4 right angles that does not have 4 equal sides. Now, most of us are thinking, yeah, I can draw a parallelogram that's got 4 equal sides and 4 right angles. We have a special name for that, and that is called a square. And so this is actually our correct answer. A square is a special type of rectangle because it's a parallelogram that has 4 right angles, and a square is a special type of rhombus. It is a parallelogram that has 4 equal sides. And so our correct answer here is going to be Eloise because that's where you would put the rectangle and the rhombuses. They both go right there. So I'm going to draw some arrows here so we can see that I've kind of drawn those. And so that square is going to be that overlap. It's a special type of rectangle and a special type of rhombus. Now, we need to draw and name shapes that go to the left, middle, and the right side of the diagram. So what do we have here? Well, we've got triangles. So we're not dealing with 4-sided shapes anymore. What do you know about right triangles? Well, it simply has a right angle. Okay, and so I can draw, let's see, I can draw a uh, right triangle that looks kind of like this. And so this is a right triangle because it has a right angle. And I could draw a few other ones. Let's go to the other side first, though. An isosceles triangle has at least 2 equal or congruent angles. It can have 3. Now, here's the crazy thing about isosceles triangles. Isosceles triangles include, let me see if I can get each of these to be about 60 here. It includes equilateral triangles, and it includes just what we would consider isosceles triangles. So both of those are isosceles. And so sometimes we get that confused because this is an equilateral triangle. And remember, the only thing that makes an isosceles triangle is it has at least 2 equal angles. Well, that has all 3 equal angles, and that's going to be fine. So we can do like this. And this is what we would consider a true isosceles that most of us learn, where it's just got the two angles that are equal, and then the third one is unequal. Now, can I draw a right triangle that is also isosceles? And yes, I can. And that's going to be right here. So what we're going to do is we're going to try to make this side and this side exactly even. And if we can do that, then this is your right angle. And then that is going to be two sets of equal sides. So yes, you can actually have a right isosceles triangle. And we actually know how big each of those angles are. There's 180 degrees in each triangle. And so if this is 90 degrees, the other two angles have to split the 90 degrees evenly, and that means that they are each 45 degrees. So a right isosceles triangle is a special type of triangle that has two equal sides, two equal angles, and a right angle. And so that's what that would look like, is that right isosceles triangle. Now, you cannot draw a right triangle that is an equilateral, so that we're not worried about trying to overlap those two. So third, we've got now drawing a Venn diagram of quadrilaterals. Now she wants to add trapezoid. Now this Venn diagram is kind of the answer to our very first problem, right? The square goes in the middle. Square is a special type of rectangle and a special type of rhombus. So let's draw a picture here of my square. And let's draw a picture of my rectangle. And let's draw a picture of my rhombus. Now, where's trapezoid go? Well, here's the problem. On the outside, I've got parallelogram. So parallelogram is a quadrilateral that's got two sets of parallel lines. So here's what I need. Quadrilateral, and then two pairs of parallel lines. And that's those two looks like L's. That's the way that we can describe the word parallel lines. So I drew just a regular parallelogram on the outside. So when we think of parallelograms, typically we'll think of shapes that kind of look like this, right? A little bit slanted, looks like a rectangle or square kind of pushed over to the side, but it's not a rectangle because they don't have four right angles. It's not a rhombus because all the four sides are not equal, but they do have two pairs of parallel lines. What about a trapezoid? Well, a trapezoid would actually go somewhere out here. It goes outside of the box. It is not a parallelogram. And so I can put one right there. I can also draw a right trapezoid down here because they are not parallelograms. Honestly, if we want to think about it, I can draw a much bigger box. So let's get my shape going here. And let's make it green. How about this? Let's draw a much bigger box outside. And I can do this. I'm going to take this. I'm going to erase this. I'm going to take my definition here. And let's just move that definition. I want to move it inside so I can do the bigger box here. All right. Well, that's not going to move for me, so we will simply move it like this. Two pairs of parallel lines. I want to move that on the inside because I want to show you what goes on the outside. Two pairs of two big L's. All right, now let's get our big box. Trapezoids go on the outside. That really is not a good looking trapezoid down there. This is going to be a larger box, and we are going to call this quadrilaterals. And so let's make everything green. Let's redraw these here. So this is a trapezoid. Now, it actually has a type of name, isosceles trapezoid. And what I was trying to draw down here is actually a different type of trapezoid. It's called a right trapezoid because it's got right angles. So those are the two types of trapezoids that we are familiar with. They go on the outside of the parallelograms because quadrilaterals simply have four sides. It's a four-sided polygon. So within quadrilaterals, you have parallelograms. Within parallelograms, you have rectangles, squares, and rhombuses. Trapezoids would go outside of the box. They don't fit. They're not parallelograms because they only have one pair of parallel sides, the two bases. They don't have two pairs of parallel sides. If you are interested in exploring the 5.5a Readiness Practice resource aligned with the intermediate or proficient version, or the Readiness Practice resource aligned with any other standard, you can find those by using the link in the video description.